So for today, I'm going to start with easy street, just like something super easy. I would just like to say, here's an equation, x, y, z. Don't write it down, just look at it. 1, 1, 1 plus t times 4, 5, 0. Well, is this an equation? Is it in parametric form? No. Could you make it in parametric form? Yes. If you did that, you could then make a system of 3 equations. You'd have the top equation, x equals 1, t, or no, 1 plus 4t. Do you get how that would be one of your 3 equations? All right, once you have a system of equations, you can use and solve that system. And let's say you figured out that t was 2. What does that mean? At time 2, something special happened. At time 2, something special happened. Well, what is that special thing that happened? Well, if you have 2 systems of equations, once you solve that system, you are finding the spot where both equations touch that same spot. Okay, so this is one equation. This is just one equation, but you can write 3 equations for the one equation. You get what I'm saying? I know this is confusing, but this is just one equation of one line. You get that's just one line? So if I were to solve it right now, there is no solving it right now. There's a million different points. In fact, let's just find 2. Everybody find me 2 points that are on this line. There's one that's like a no-brainer. And then another point. So find me 2 points on this line. There's an infinite number of solutions to this. I just want you to find 2. The challenge is when you want to try to find points that are on this and are also on another equation. All right, next, of the 2 things that you have here, you got one of them is a point, one of them is the actual vector. They look like the same thing, but one of them is actually different than the other. One's a vector. All right. Jack, is your phone out again? Oh, good. Can you tell me, Charlotte, which of these 2 is the vector? Yeah. That vector has a length, a magnitude. Would everybody please figure out what the magnitude of this vector is? Only one of these 2 is the vector. That one's got a magnitude. There's your 2 points you should have had before. You put in 0 and you get 450, which is... No, you don't. No, you don't. You put in 0, you get 111. And you put in 1 and you get 5, 6, 1. I think I've got it right now. Raise your hand if you agree. Okay, good. Now, if I go and make this magnitude, if I called this vector v, the magnitude means you put these bars around it. You got to know that shorthand on the test. If we just put the bars around it, that means what's the magnitude? And that's going to be the square root of 16 plus 25 plus 0. So I'll just say 16 and 25. Square root of 41. Raise your hand if you had square root of 41. Cool. Now, I'm going to ask you a question. What's the speed of this vector? It's a vector that started at the point 1, 1, 1 and then moved in this direction at a speed. If I told you that the answer is actually very simple, I want you to talk to the kid next to you and what's your theory? What's the speed of this vector? Talk to the kid next to you. Rows 1 and 2, rows 3 and 4. You guys talk to the back.
Maybe it's just 450.
All right, who has a theory? What is the theory that kind of makes sense to them? Yes?
It's just like the slope of the vector, so isn't it just 4, 5, 0? Every time you're going up by 1.
Okay, so 4, 5, and 0 are definitely key to the answer, but you're overthinking it. So,
T 450?
nope, thank you for, yeah, you're right that it's 4, 5, 0, and it also involves the t, but it's simpler than all that. It's the square root of 41, because that's how far it goes when you go over 4. Up 5, and then out. I like to think of it as out, the third one. 0. That's how far you go. This is how far you're going to go every time of 1. At time 1, you're going to go that far. So that is the speed. What's that, Tim? Yeah, it was the 450, but it gives you an answer of square root of 41. Okay, so basically, the speed is just the same as the magnitude? Yes, it is. All right. Now, we're going to make another equation. Make this in a different color, please. Please change colors. XYZ is going to be, we're going to start at 0, 0, 0 for this one, plus lambda instead of t. All right. Now, I would like you to write a system of equations for this one. You got an x equals, a y equals, and a z equals. And then for this one, also an x equals, and a y equals, and a z equals. And then, if you don't set the x equal to the x, you'll just, all this is one equation. You have to set it equal to the other equation. And then you solve the system, and you'll know that something happens. We're going to talk about whether that's a collision or whether it's just that they intersect at that spot, because there's a difference. Just because they both go through the same spot, which I think they do, doesn't mean that they're colliding at that spot. Because if you and I are in the same spot at different times, that happens all the time. Just like when you walked through the door today. You all went through the same spot. That doorway area, you all went there. You were all in that spot. You're just there at different times. I'll pause for a second while you solve this. First write the system equations, then set your x equal to your x, so make them equal, and then solve that system. And at the end, you'll have the times that are the important times. At the end of this, you don't know the point where they intersect. You'll just know what times they were at the same spot. Okay, if you could talk to the kid next to you, if you got lambda and t, or if you're lost, ask for help.
Did you give 1.5? That's what I got. Because you plug in the lambda, so you set the y's equal to each other.
Yeah. Oh wait, no, I just did that with the math wrong. Yeah. Sorry, my bad. I can't.
Did you just do 4 divided by 4?
4 divided by 4 equals 4.
Yeah,
Look at math sheet.
hey, get that shit.
Yes.
Would there ever be questions on the test where we have one of them that doesn't
I'm doing the quiz inside.
equal like 1 plus t0?
Yes.
Okay.
All right. So here is my 3 equations. I hope you can see where I'm getting them from. I'm trying to show you via color coding here. And last but not least is this one. Oopsie. Highlighting, Mr. Server. That. And then the last one is 2 lambda equals 1. So I was asked by one of the students, is there ever a time when you don't get a nice one like this, where it just comes out to lambda equals 1/2? Yeah, you don't have to get that lucky, okay? That is really lucky to just have one variable alone, and I wrote this wrong, sorry. And I get lambda equals 1/2. Yay, I'm done. I already know one of my 2 key spots. Could you have solved these 2 without even using this one? Yes, you could. And how would you? Well, you could solve this one for lambda, solve this one for lambda, and set them equal. Or you could solve this one for t, and then put it in here where t is, and then solve for it that way. So there's substitution or elimination would work to solve this system. But this is the part where we're in honors pre-calc. I'm not supposed to be reminding you how to solve systems of equations. But yet here I am doing it. I'm just saying you're supposed to know how to solve a system. I will admit that you don't do these very often, so that's why I'm taking the time to talk about how you would solve the system. But this is a really great shortcut. Since I know lambda is 1/2, I can just go boom. I put in 1/2 right here or here. And either way, I can solve it for t. And in fact, I should really check and make sure they come out the same. So this one comes out to 5 equals 1 plus 4t, and that means t must be 1. Or this one comes out to 6, 1 plus 5t, t must be 1 again. Either way, t equals 1. So t equals 1 and lambda equals 1/2. Am I done? No. I know that at this time, something special happens. Now, since those times are different, do you get that when we solve and find this magical place, that they will not be colliding there? Think about it. They're there at that spot at different times. So they both will go through that spot, which is what spot? Well, I already know, because right down here, I figured out when time was 1, it was 5, 6, 1. I better just make sure in the other equation that when time is 1/2, remember lambda was 1/2, that I also get 5, 6, 1. So I'm going to make my little lambda x, y, z chart and make sure that when I put in 1/2, I really get what I thought I was going to get. And I get 5, 6, 1, which is the same point. They both go through 5, 6, 1, but at different times. So did they intersect? Did they intersect? I have half the class saying yes and half the class saying no. The 2 keywords are intersect and collide. They're different. So let me ask you again, did they intersect?
Yes.
Yes, they intersected because they both went through that same spot. Did they collide? No, they did not collide because they weren't there at the same time. Intersect means cross. So they did cross paths, but they were not there at the same time. See, this is the thing that's different about, if I just have 2 lines and they intersect, previously, that was the only question, is do they intersect? But vectors are kind of like a little guy running along this line. There's just a little guy running along that line, and there's over here, we have somebody running along this line. And they can go along the same path without ever touching each other, because they're there at different times. It's different than a line that's just always existing at all spots at once. A vector is different. It's a little guy running along that line. Okay? All right. Okay, so I'm going to give you one last one, and this is the hardest kind. Then we'll review some real basics, and then you'll take the quiz. All right, so here's one last one, all by yourself. Do not copy this down. You can just skip to the good part, which is solving it. 1, 2, 3. plus t times 4, 5, negative 2. Now you can write an equation set for that because you're going to be seeing if that and this intersect or collide. And if so, where? 0, 4. If they collide, they're doing it at the same time. So lambda and t would have to be the same. Collide means they're there at the same exact moment. I'll pause while you see if this set of vectors intersect or collide. I'm just going to get it started so you can see if you made any mistakes initially. X equals 1 plus 4t. Notice I'm making it in a parametric form. You don't really necessarily care that it's called parametric, but it is. Okay, I would take a second and just make sure that your master equations boiled down to the same ones as mine. Then, from there, you'll need to solve the system. Now, you do get to pick. I personally would probably pick these two to solve, just because the top one's got only 3 parts instead of 4, so it's just slightly easier. Now, can we just do this whole thing and ignore this bottom equation? No, you really can't. You could, but you'd be taking a horrible risk because 2 vectors that don't include their z vector, if you don't look at this z, you might think they intersect when they really don't. So bottom line, if you've got an answer, some of you maybe solved these 2 and you got your answer, check it in this equation and make sure it works. So if you think the answer is 1 and 3, if that's, what you think that it comes out to is t equals 1 and lambda equals 3, just stick them into the final equation and see if it worked. All right, so I'll solve this the rest of the way. I'm going to subtract, or I'm going to solve this one for t right now. You could have done this a million ways. Actually, x. Well, then I got a big fraction. I'm going to have a fraction either way. Okay, I'm going to solve it for x. I'm going to say x equals 1 plus 4t over 5. That's not an x, that's a lambda. Sorry about that. I couldn't read my own writing. I think I had it and then I changed it to make it better, better x, but it wasn't an x, it was a lambda. Okay, lambda. There. And now I'm going to go down to this one, and I'm going to write 2 plus 5t equals 4 plus 3, and that's where lambda would go. But I now know lambda is 1 plus 4t over 5. Now, I'm going to subtract 4 from both sides. That's easy. Now, you know my favorite saying is if you can factor it, you should. But what's my second favorite saying? Clear the fractions. So, I'm going to multiply everything by 5 here. And I have to multiply this by 5. But it's really distributing that to both of those parts. So, this will be negative 10 equals 25. Sorry, plus 25t equals, and those cancel. And now I can multiply out the 3. 3 times 1 is 3 plus 12t. Ooh, that got a lot easier when I got rid of that fraction. Okay, now I'm going to, I got variables on both sides. I'm going to get rid of the smaller one. Keep saying equals, plus. And there. And oh, this is going to work out nice. 13t equals 13. T equals 1. Raise your hand if you got t equals 1. Cool. Then, once I know t equals 1, it's so much easier. I can now go to the other equation. Actually, either equation. And stick t equals 1 in there. Now, I'm going to choose to put it into this one. You could have picked either one. So now if t equals 1, and now I'm going to rewrite this equation with a t equals 1, 2, plus 5 times 1, is t equals 1, equals 4 plus 3 lambda. And that means 7 equals 4 plus 3 lambda. Subtract 4 from both sides. Negative, nope, positive 3 equals 3 lambda. Lambda equals 1 also. Now, since lambda was 1 and t was 1, and we're at the same exact time. So if they're at the same time, then that means they collided. Raise your hand if you knew that they were colliding. Okay. So now I'm going to put in a x, y, z, and this is a t, x, y, z. And then up here, I'm going to put in a lambda x, y, z. And I'm going to make them each 1. And then when I put in my 1 into my original equation here, I want a 1 there and a 1 there. I get the points. X will be 1 plus 4 is 5. Y will be 2 plus 5 is 7. And Z will be 3 plus negative 2, which is 1. 571. Can anybody verify 571? Cool. And then if I put in a 1 here also, hopefully it comes out to 5, which it does. 7, which it does. And 1. Yep, they both hit 571. They collide at 571. At t equals 1 and lambda equals 1. Whew. Now that is a serious math problem. Now I've got a momentous statement. I just taught you the last thing from honors pre-covering. That's it. You've made it to the end. Okay, so considering that's a really hard problem, that's kind of cool to end that way. So now you just gotta like convey your knowledge of this information to me on a little quiz that we're gonna have, which is so much easier than what we just did. Okay, and then on the test on Friday, which will be a lot like this. Okay, and then we have review for the final, and then the final, which is all review of all old stuff. So you just made it to the end of honors pre-calc. Cool. All right, let's just do a last little thing that will help you on the quiz you're about to take. So this should be a relief considering how this stuff was. What if I just asked you for how long is this vector? 5, 1, 2. And I know you might be like, that's too easy, Mr. Server. We can do that in our sleep. There'll be a follow-up question. First, just tell me how long that is. That's a vector. What's its magnitude? That's it. Write it. All right. Did you get square root of 25 plus 1 plus 4, which would be square root of 30? Raise your hand if you had square root of 30. Cool. Now make this into a unit vector. You did have that while I was gone. I haven't talked about it in a while. Let's see if you remember. It's not that hard. You just have to put something in front of the vector to scale it down so it has a size of 1. Unit means 1, right? Unit circle, 1. So we want this to have a length of 1, and you might be like, but it doesn't have a length of 1. Yeah, so we need to multiply it by something. If you understand it, you already wrote it. 1 over the square root of 30. If you don't understand that, think about it. If its length was the square root of 30, if you multiply by 1 over that, you just scaled it down to a length of 1. Now, could you multiply it in? Multiply this here and there and there. Yeah, you could. And you could just make it look like a more normal vector, but I would not make you do that. Okay, then last thing is, let's say I wanted to have a vector that was in this direction, but would only have a length of 2. This is the length of 1, so then just times it by 2. Couldn't you put the 2 on the top right there? Yep, you could. That would also work. Now it has a length of 2. What if I wanted it to have a length of 21? 21 over square root of 30. All right. So that's a review of something that you learned while I was gone. And last is, do you remember if the dot products are 0? Something special happens. It's going to be V. It's going to be T. 2, 1, I don't know what. If I make that question mark into something just right, these two will be perpendicular. Would you please make that blue question mark be the right number so that these end up having a dot product of what? Dot product of 0 makes them perpendicular. So figure out what the question mark has to be. Pausing. All right. Could you use guess and check to do the dot product and eventually find it? Sure. But here's how I'd do it. 5 times 2 plus 1 times 1 plus 2 times I don't know what, and it needs to all equal 0. So then this means 10 plus 1 is 11 plus 2n equals 0. So 2n equals negative 11. So n would have to be negative 11 halves. Who had that one right? Good. If you were trying to guess and check, you would not have figured it out, would you? Nobody's going to guess negative 11 halves. Know what I mean? So do you get what I did there? This times this, that times that, and that times that. All added up. Had to equal 0. All right. Get started on that quiz. You got to finish it by the end of the hour. You'll hand it to me and walk out the door. Your homework is the same homework as yesterday, except you add on the plain question. Pausing. Actually, that's the end of the video for today.